Hey, welcome back, 8th grade. We're going to jump right back into problem 3.2, comparing costs and solving more linear equations.
All right, so here we have Ms. Lucero wants to install tiles around her square swimming pool. She finds the following two advertisements for tile companies. We've got Cover and Surround It, $1,000 for design and delivery, $25 per tile after 12 tiles. Tile and Beyond, $740 design and delivery, $32 per tile after 10 tiles. So two very, very unique situations. Fortunately, they give us the actual equations. So Cover and Surround It, you have the cost of Cover and Surround. It's going to be the $1,000 plus the $25 times the n minus 12. And that n minus 12 ends up being that tile that comes in after the 12th tile. Tile and Beyond, you have the cost of Tile and Beyond, $740 plus $32 times the n minus 10, which is going to be the number of tiles after the 10th tile. So in this case, what we're going to be doing is comparing these companies to see which one Ms. Lucero should go with. So the idea is we want to understand these equations, make sure it's clear, but the big part is Ms. Lucero wants to know when the cost of each company will be equal. So this idea is she wants to use the equation, the cost of Cover and Surround is equal to the cost of Tile and Beyond. So that takes us into our first question. So, without using a table or a graph, find the number of tiles for which the two costs are equal. Well, if we can't use a table, we can't use a graph, what's left to use? The equations that we just had right over here. So, let's get those.
So, as we just spoke a minute ago, we're going to do the cost of the cover is going to be needing to be equal to the cost of the tile and beyond. And so we're going to take both those equations and put those together and make them be equal. So I'm going to set this up here. Take this one, it's going to be 1,000 plus 25 times n minus 12. It's going to be equal to 740 plus 32 times number of tiles minus 10. All right, so we're looking for the number of tiles for which these companies and their costs will be equal. So right away, I need to begin to look carefully at this. I do have a 25 right up against the n minus 12 and a 32 right up against the n minus 10. I'm going to need to distribute those through. So in both cases, I have to distribute that through. So I know I'm going to have a 1,000 plus 25 times n is 25n. Then I'm going to do 25 times that negative 12, and to save 20 sometimes here, it's going to be 300. And that takes away that parentheses. And then I'm going to have my 740 plus, distributing that through, 32n, and that times 10, I know that one, minus 320. All right, so we start looking to combine some like terms. I do see right here I've got 1,000 minus 300, which I know is going to give me a 25n plus 700 is equal to, same thing here, 740 minus 320, just to be safe. 740 minus 320, so it's 420. So I'm going to have a 32n plus 420. And then we start moving these around. I want my n to be positive, so I'm going to bring the 25n over here. So minus 25n here, minus 25n here. These are going to cancel. 32n minus 25n is going to give me a 7n. I'm going to bring this down. Subtract 420 here, subtract 420 here. This is going to be canceling. 7n is equal to 280. And it gives me a little bit of a warm fuzzy, but I think we got this one here. Divide by 7, divide by 7. 280 divided by 7, going to go in exactly 40 times, which is nice. So it turns out in these companies, when the companies are equal, it will be at 40 tiles. A2, how can you check that your solution is correct? Well, what we can do is we can go back to these equations up here, but put 40 in this time instead. So let me do that here for us. So 1,000 plus 25 times 40 minus 12 is equal to 740 plus 32 times 40 minus 10. So we put that, we change the value of n, put that in there. So what I have here is going to be 1,000 plus 25 times 40 minus 12 is going to be 28. See, that's going to be equal to 740 plus 32 times 30. All right, so 1,000 plus 25 times 28, 700. It's going to be equal to 740 plus 32 times 30, 960. I add both these together. This one's not too bad. 1,700 is equal to, let's take that again, plus 740. Okay, look at that. We did that right. They're equal. That's how we can check. So we can go back and plug the value of n back in the equation to see if it is correct. All right, A3. How can you use a graph or a table to find the number of tiles for which the two costs are equal? Well, it doesn't say that we have to make a graph, so I think that we'll save some time here. But we could use a graph if we actually drew the graph, did the x and y axis, plotted the points. The graphs would actually cross at a specific point. They would cross at that place where it would be 40 tiles and the cost would be $1,700. So you can see that would be one value and this would be the other value. So it turns out our ordered pair would be 40, 1,700, and that would be n number of tiles, and that would be the cost in that case. That's where they would cross right there. What about a table? How did we know about when these costs are equal from a table? Well, we plug numbers in and kind of go all the way down through. We could do 10, 20, 30, 40 and actually calculate the information out, and we get the exact same cost again from a table. All right, guys, continuing here with A4. For what number of tiles is tile and beyond cheaper than cover and surround it? So they give us this inequality here. The cost of tile and beyond, when's it less than the cost of cover and surround it? And explain our reasoning. So basically we can do the exact same work that we just did in part A1, but using this inequality symbol instead. So let me get that set up for us here. So we're gonna actually take this, where we reverse them, the 740 plus 32 times n minus 10 is going to be less than the 1,000 plus 25 times n minus 12. Now we're going to do the exact same work that we went through to solve this. So if you want to take some shortcuts, you can see that we actually did some of that distribution here work back on A1. So I'm going to bring some of those pieces in along the way to simplify that, but I'll still not cut too many corners. So 740 plus 32n minus 320 is going to be less than 1,000 plus 25n minus, and remembering that that 25 times 12 was the minus 300. Okay, continue to simplify. We have that same work over here. We have that is going to be 740 minus 320 was 420. So I'll do 420 plus 32n is going to be less than 700 plus 25n. All right, continue to do that work. I want my variables to be positive, so I'll do minus 25n here, minus 25n here. This is going to cancel. I'll be less down to 7n in that case. So 420 plus that is going to be less than 700 minus 420 and minus 420. This is canceled, so it's going to be 7n is less than that same 280 divided by 7 divided by 7, and n is going to be here again, that 280 divided by 7 is going to give me 40 in that case. So in this case, what they're showing here is whenever the number of tiles is less than 40, this tells us that tile and beyond will be cheaper than cover and surround it. So again, so here's our initial thing. When is cover or the tile and beyond less than this, the cover and surround? So whenever the tiles are going to be less than 40 tiles purchased. When they were equal, when it was 40, whenever the numbers are less, so it could be 39 or 38 or anything down that way in that part there. What we need to know is that whenever n is less, number of tiles is less than 40, that means that tile and beyond is less expensive. But that would also mean when tiles are greater than 40, that means the cover and surround it is going to be the less expensive option. Moving on to part B. So we're going to actually be asked to use the same strategies that we did in some of the same questions from problem 3.1 and question A that we just had up here to do some of these solving for the equation for x and to go back and check your solutions. So I'm going to do B1, but then give you guys a chance to do the rest of those, but I'll post the answers so you guys can see what's... Here we go, B1. So first of all, we have distributed property going. So I need to distribute this 2 times the 3 and the 2 times the 4x. So when I do that, I will have 6 plus 8x. I also have my plus 5 here and my 3x. Okay, so I'll start doing some simplifying. 3x is equal to 5 plus 6 is 11 plus 8x. Now I do have variables on both sides, but I already have one on this side, so it might be easier to move this instead of having to move the 11 over a little extra there. So I'm just doing minus 8x here, minus 8x here. This cancels. I have negative 5x is equal to 11. Divide by negative 5, divide by negative 5. Turns out that we'll have x is equal to negative 11 over 5. And so we're going to be asked to check that. So in this process, we got to go back and take that value and plug it in. I'm going to plug it in right here for this one with the 8x in that case. So we'll do that. Come here, I'm going to do 3x is equal to 5 plus 6 plus 8 times negative 11 over 5. So to do that work first, this is going to be like 11 over 1. There's no cross-canceling going on in that case. So I'm going to be doing, this is going to be a negative 88 over 5. This one over here, I need to plug that in as well. That's going to be a 3 times that negative 11 over 5. So I will have here negative 33 over 5 is equal to 5 plus 6 plus that negative. Now, I don't know about you guys, but I'm already seeing the setup here could work. These already have that same denominator of 5. So I'm going to add this 88 over 5 here plus 88 over 5 here. That's going to cancel. So wait, those are both over 5, so we're still going to end up being over 5. So I really just do the negative 33 plus the 88, which I can see is going to be equal to 55, which I like that. That's those warm fuzzies coming in, which I already know is 11. So bring all that down. I've got my 5 plus 6, which I know is 11, and that checks. There it is.
So at this point, go ahead and do B2, 3, 4, and 5. And I'll pause the video here and you guys can do that. And then I'll post those answers here in just a bit.
All right, so for B2, we would have x is equal to negative 1 over 11. B3 is x equals negative 1/5. And 4x equals 1. Now, if you noticed on number 5, it's the exact same equation, but turned into an inequality. So you basically have the exact same result, just with the less than symbol in there for that.
For part C, they said for each of these pair of equations, find the value of x that makes y1 equal to y2. So basically, you're going to actually set these up to be equal to each other. What we do is like we did before. Remember on part A1 where we had these equal, you're going to rewrite these as being equal to like this. You see we took those, we dropped the y's, had them equal to each other here, and then rewrote the equations because this is what they equal in this case. So for this, we're going to go ahead and distribute that 3 through on this side. So 3 times 2x and 3 times the negative 5, which will give me a 6x minus 15. Same thing over here, 2 times 3x and 2 times the negative 1 is equal to 6x minus 2 plus x. Now I'm going to go ahead and simplify this side over here, but I know I've got 6x minus 15 is equal to, this is going to be a 6x plus x, so it's going to be 7x minus 2. This side's a little bit bigger, so actually larger, so I'm going to move my negative 6 over here, or minus 6 on both sides, I should say. I'm going to have a minus 15 is equal to x minus 2. Add 2 here, add 2 here. This is going to go away. X is going to be equal to 15 minus 2 is going to be a negative 13. This is going to be a chance for us to practice a little bit what we were looking at back towards the end of that week we were last together, where they're going to be asking if our equations are going to give us a finite number of solutions, which would mean one value for x, an infinite number of solutions, which could be all numbers would work, or no solutions. Remember that you get that false statement. So since on number 1, we got the actual statement being true, I bet on 2 and 3, you're going to either get a no solutions or an infinitely many solutions. Then they actually want you to go in and graph both of these, because if you notice when you distribute that 3 through, it will be in slope-intercept form. So you're going to graph both of those and have a chance to see what those look like.
Here you can see the graph for C1. The lines cross at negative 13.
All right, here we go. C2. We can begin. We need to start off by distributing the 3 through here and the 3 through here. So give us our 6x minus 15 is equal to distributing the 2 through here. It's going to be 6x minus 2 plus 7. So this side's already been simplified. And I've got 6x minus 2 plus 7. So this negative 2 plus 7 is going to give me a 6x plus 5. Got to begin to move this around. So I'm going to do my minus 6 here, minus 6 here. Just like we saw in class, notice how both of these cancel out. They both become 0. So I'm left with a negative 15 is equal to 5. And that actually is a false statement. That tells us this is not true. So that means this is going to be a situation where the answer is no solution.
Here's a graph for C2. You can see there's no solution because the lines don't cross.
That brings us to part C3. So again, distributing this through here into here. We're going to have our 6x minus 15 is equal to 2 times 3x and 2 times the negative 1. It's going to be 6x minus 2, and then our minus 13. This side's simplified, so 6x minus 15 equals 6x negative 2 minus 13. Remember, same signs, add and keep, so I got minus 15. Hey, look, these are the same. They're going to be identical. So in this case, minus 6 and minus 6 cancel and cancel. I've got a negative 15 equals negative 15. Now it becomes a true statement. So this is all numbers. Or infinitely
Many. That's how that would work. I don't know how to spell infinite. 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 That's an I. Infinite numbers. Okay.
Here you can see that every number would work because the lines are exactly the same.
All right, everybody, go to work on those. Bring your questions tomorrow to the Google Meet, and we can process through some stuff if you're stuck. All right, guys, have a good one. Later.